Okay, this is still in section 2.6. We're still working with word problems and setting up equations. This is an important little section on consecutive integers. An integer is a whole value. You can see I have the set of integers highlighted here in brackets. The 0 is an integer in the middle, and then you have positive whole units to the right and negative whole units to the left. So that is the set of integers. We are working with three types of integers here. We're going to start with consecutive, then we're going to look at consecutive even, and finally we're going to look at consecutive odd integers. So an example of consecutive integers might be 11, 12, and 13. That would represent some consecutive integers. So how do we represent those with mathematics? We would call the first one x. The second one is 1 larger than the first, so we would call the second one x plus 1. And the third one is 2 larger than the first. 13 is 2 larger than 11. So we would call the third one x plus 2, and so forth. So if the first integer is 11, then the second integer is 11 plus 1, which is 12, and 11 plus 2 would be the third integer, consecutive integer, which is 13. Okay, so those increase in increments of 1. Consecutive even integers go up in increments of 2, 8, 10, 12, for example. So we're going to call the first one x. The second one is 2 larger than the first, so we'll call the second one x plus 2. And the third one is 4 larger than the first, so we'll call that x plus 4. So again, if the first one is 8, the second one is 8 plus 2. And the third one is 8 plus 4. So that's how you model consecutive even. And for consecutive odd, you would think it would do something different, but it doesn't. Let's say you have 15, 17, and 19. The first one, 15. The second one is still 2 larger than the first, so x plus 2. And the third one is still 4 larger than the first. So we model those consecutive even and consecutive odd in the same way. So if we start here with 15, you can see that 15 increased by 2 would bring us to the 17, which would be the next one. And the 15 increased by 4 would bring us to the third consecutive odd integer. All right, so I'm going to do a couple of quick problems with you here. Find 3 consecutive integers whose sum is 69. You've got to read these very carefully. Am I dealing with plain old consecutive, or am I dealing with consecutive even? What am I dealing with? So this is consecutive. So you can see I've written down my model out there. X is the first, x plus 1 is the second, and x plus 2 is the third. So what I want to show you is that I've got these 3 numbers that are going to be added together. So here they are. And they total up to 69. So first integer, second integer, third integer. So watch how I'm going to model this. The first one is x, the second one is x plus 1, and the third one is x plus 2. So here are my first, second, third models there. All right, again, let me make sure I know where my equals mark is. I'm looking on the left-hand side. I see several things that can be combined. I see some variable terms here that could be combined. So let me do that, x plus x plus x. And then I see some constant terms that can be combined, 1 and 2. There's my equals mark, and there's the 69. Okay, so I've got it all modeled and shortened, compressed by combining like terms on the left-hand side. I'm going to subtract 3 from both sides. Copy down the 3x, the 3, 0 out. Here's my equals mark. This comes down to 66. Dividing by 3, the first number is 22. So you don't stop there. It says find 3. So we don't stop with just the first. The second one is 22 plus 1. And the third one is 22 plus 2. So our answers are 22, 23, 24. All right, so that's our first example. This next one involves consecutive even integers, and I've modeled them for you here. The first integer is x, and the second integer is x plus 2. The sum, we're looking for their sum. So here's the sum of the first plus the second, and that sum comes up to be 78. So here's how I write it down. Here's the first one. Here's the second one. Their sum is 78, not 74. Here's my dotted line separating left and right. Here are some like terms over on the left that need to be compressed, condensed, combined. Subtracting 2 from both sides. Let me come up here and put it. This is going to be 2x equals 76. I hope you see that. And then dividing by that numerical coefficient 2. Looks like the first one is 38, so again we don't stop there. To get the second one we do x plus 2. So 38 plus 2, my second number is 40. So 38 plus 40. And the next one that we're looking with at consecutive odd. And again, you can see how I've modeled it out there. It's the same model as for consecutive even. These go up in increments of 2. So I'm going to show you the sum of 2. And that's going to add up to 60. So here's the first. Here's the second. Here's the sum of 60. I'm skipping steps because I don't really think you need to see me belabor this. Sorry. So the first number is 29, and then when we increase that by 2 to get the second number, 29 plus 2 is 31. So my numbers are 29 and 31. All right, so quickly moving on, I wanted to show you this last one. Find two consecutive integers, and notice we're back to consecutive this time. So the first one is x and the second one is x plus 1, such that twice the first plus 3 times the second. All right, let's see if I can. Twice the first plus 3 times the second. This is the first, twice the first, and 3 times the second equals 83. All right, so twice the first, 3 times the second equals 83. So there's twice the first, 3 times the second. Here's my left-right dividing line. I've got a distributive property here that I'm going to deal with first. I see a couple of like terms here that I'm going to combine or condense on the left-hand side. Now I'm going to start moving some things, so I'm going to subtract this 3 from both sides to isolate the variable 5x. And then dividing by this numerical coefficient in front. Looks like x is 16, and so x plus 1 is 17. So let's see if this checks. Twice the first plus 3 times the second, question mark, does that equal 83? So this is 32, and I think that's 51. Yes. Does that add up to 83? And yep, it does. And so I've checked it, and I can see that what I have done here makes sense. Balance is out, and we're done.